Hello everyone, thanks for attending my presentation. My name is Kla from Monash University, Melbourne, Australia. So today I'm going to present my latest work titled JITBot, an explainable just-in-time defect prediction bot. So this work is a collaboration work with Mahidol University, Thailand. So today software systems evolve rapidly. They are often written in multiple languages by many people over a long period of time in order to fix bugs, add new features, and improve code quality. For example, Google reports that 50% of their code base changes every month, and such rapid evolution of software poses a critical challenges to SQA teams to ensure the quality of their software system. So many SQA tools and techniques have been heavily invested. For example, some use static analysis tools to generate warnings, but they often produce lots of false positives. And some use CI/CD for test automation, but build and test execution time are very slow for large-scale software systems. Some use code review, but it is still time consuming. So that means we cannot perform SQA activities for all code commits. And the million-dollar question is that given the limited resources, how can we effectively prioritize SQA activities on the most risky commits? So just-in-time defect prediction has been proposed to predict if a commit will introduce defects in the future or not. And normally we start extracting the characteristics of defect introducing commits from historical data. And then we're going to train a JIT model using this kind of training data. And given a new commit or code change, we can generate the risk score to practitioners to early warn the developers if this commit is risky or not. So SQA resources are prioritized effectively. However, such models still have limited adoption. And when we talk to practitioners, they often ask me questions. So like, why is this commit risky? And how can we mitigate the risk? And these are the two important questions that have not been well explored. In particular, there exist two main challenges. First is about a lack of explainability of the predictions of just-in-time defect prediction models. And our recent work, which published at TSE, is among the first to address this challenge by introducing alarm model agnostic technique to generate the explanations. And the interesting findings is that we found that given the same defect models, different predictions have different explanations. And it means that the general explanation from ANOVA analysis or variable importance is not applicable to all predictions. And we need, that's why we need a more fine-grained explanation for each prediction. And we also, when we present the results to practitioners, 65% of the participants perceive that such explanations are very useful. However, LAM has never been integrated into the just-in-time defect prediction model. And another challenge is about a lack of CI and CD integration. Recent work by Wan et al. Found that 64% of the participants perceive that a lack of integration into CI/CD pipelines is one of the most adoption barriers. So in this work, we present a JITBot architecture to address the aforementioned challenges. We start from mining GitHub repository to prepare JIT datasets, and then we build JIT models, generate the predictions, and the key highlight part is that we employ alarm model agnostic technique to generate the explanation to get a deeper understanding of what features contribute to the final probability. And then we're gonna wrap up everything as a JIT Python framework. Once a pull request is created, it will send a Git webhook to the Probot framework, and the Probot framework will post the data to our JIT Python framework. And our JITBot will compute the risk score, generate the explanation, and return the results to the Probot framework and to the pull request. Then practitioners can confidently make data-informed decisions if this PR or pull request is ready to merge or not. Once it is ready, we can just approve and merge it. We evaluate our JITBot framework with 21 open source software projects. We train the model with 8 commit level features like entropy, numbers of add lines, numbers of delete lines, and build the model using a random forest classification technique. Our JIT models achieve an AUC of 0.82 and an F measure of 0.58. So the model predictions are quite accurate. Now we will discuss a use case scenario. So let's imagine that developers have a stream of pull requests to be reviewed. Exhaustively reviewing all pull requests are infeasible due to limited resources. So given a stream of pull requests to be reviewed, which one is the most risky? And our JITBot is designed to generate 3 types of explanations. How risky is this commit? Why this commit is risky? And how to mitigate the risk. Like in this example, we found that this commit has a moderate risk of 63%, and this moderate risk of this commit has to do with the low experience of developers who commit this code. And thus, JITBot suggests that the author of this commit should ask senior developers to review the code. And thank you for your, that's all for my presentation today. Thank you for your attention. If you have any questions, I'm happy to take now.